Cross-curricular maths and science. Does this approach enhance our understanding of how to use and interpret data handling? The presentation will discuss the use of data handling within cross-curricular maths and science. More specifically, whether the cross-curricular approach is more beneficial in teaching data handling to children. I've chosen this area because data handling is something which can be used in both maths and science. However, the concept can be difficult to understand. The purpose of this presentation is to discuss whether the cross-curricular approach proves to be more helpful for pupils when they learn about data handling. To start with, I will first discuss general points relating to data handling on the next slide. As previously mentioned, data handling is a subject which can be used in both maths and science. However, the concept of data handling is more likely to be taught in maths lessons before it is used in science lessons. Data handling involves being able to read and design charts, often based on results from investigations. The data is usually quantitative, containing numerical results, and this contributes to writing the conclusion and answer for an investigation. Okay, so here are two examples of charts that can be used. There is a pie chart which is divided into sectors of a whole circle to show the overall percentages of findings. An example can be to find out the favourite colour of a class and discover which one was the most popular choice. There is also a bar chart which can be used to show the numerical values of different variables. This example is a data table to show the overall sales figures of fruit and vegetables over 3 years. Here are some more examples. Another bar chart and also a line graph. The bar chart shows the favourite animals of a Year 1 class, and the line graph shows the average temperatures over a 5-day period. What is not known, however, is whether the charts were easy to complete after the evidence was obtained. There are many examples of charts which can be discussed, but the problem remains that the concept of data handling can be difficult to understand, especially for primary ages. The cross-curricular approach to maths and science is argued to enhance our understanding of data handling skills, and here are some arguments for why it can do so. Okay, so for the arguments for cross-curricular links, I'll start off by talking about Janet Ainley, who in 1989 argued that maths should be used across other subjects to engage children in the learning and appreciation for the subject. This links to the argument that maths, especially data handling, can be difficult but also boring. Farmery, 2005, went further with this argument and claimed that the use of science may motivate pupils in their learning. Farmery referred to cross-curricular maths and science, claiming that maths skills will empower pupils through the use of scientific inquiry. Pupils will find a cross-curricular approach more engaging because more practicality is applied. The pupils would be able to conduct their own experiments as well as have access to scientific resources. Jarvis, in 2009, who also supported this, says that science provides an ideal opportunity to enable pupils to apply and understand mathematical ideas. Jarvis referred to using investigations and experiments to be carried out by pupils so they may have the opportunity to record their findings by designing charts of their own. A bit earlier than Jarvis, there was research conducted by Smith in 2004, who supports the argument by saying that maths is the language of science and technology. In other words, maths and science link together very strongly, but the use of ICT can also be applied. And on the next slide, there is more of a discussion into the use of ICT in this cross-curricular aspect. Okay, so the use of ICT appears to be a great way to support cross-curricular maths and science, especially data handling. Microsoft Excel is often used to design charts based on results. The program is reliable, it's practical, it's easy to use, and it will produce good chart designs. According to Bull in 2003, spreadsheets are mainly used in primary science for data entry because it can develop pupils' skills in being able to understand pattern seeking and fair testing, both very important skills within maths and science. This is further supported by Beauchamp in 2013, who argued that the use of ICT in data handling is one of the strengths. He says that neat and well-presented charts can be produced, further encouraging pupils to be engaged within their learning. It is also a good way to show creativity, which English in 2006 argued that pupils can produce various data files relating to personal experience. This links to the cross-curricular approach because pupils can further enhance what they know about data handling and use this as an opportunity to conduct their own experiments and produce their results. It allows pupils to take further steps in their work, allowing more progression in their educational achievement. Okay, so some advantages have already been discussed, mainly supporting that cross-curricular approaches can develop our understanding of data handling, and there are some more on the next slide. So first of all, there is a strong use of pedagogy present in the cross-curricular approach. The data handling skills which are taught in maths are being used in science, allowing pupils to analyse findings in experiments, to apply their knowledge to their research findings and chart designs, and most importantly, to enhance their understanding of data handling through practical activities. According to Bowden in 2009, measuring and counting are key features of scientific investigation, therefore it demonstrates links between more than one area of maths. So what Bowden was saying was that it can apply to not just data handling, but it can apply to measuring, which is another aspect of maths. Also, according to Hendry in 2013, there is increasing expectation in accuracy and precision through the use of data handling. In other words, pupils need to show that they can produce strong evidence through the use of graphs, and they must also be able to present them in a neat and professional way. Therefore, the cross-curricular approach can be beneficial in ensuring that plenty of practice is put into enhancing pupil skills within data handling. The more they practice, the more their data handling skills will improve. And on the next slide, there's an argument. Okay, so this slide will discuss Naomi Hiscock's research in 2012. She makes it very clear in her report that the cross-curricular approach to maths and science should be considered a lot more than it already is. She discusses 3 areas of data handling, as shown on the arrow key, that pupils need to learn and understand. She says that to be able to measure, children need to be motivated to make greater use of practical work. And she says they should be able to present their findings as data, but they should also be able to interpret data. Now, these are just a few advantages, but obviously I need to discuss the disadvantages, which will be on the next slide. Okay, so in terms of the disadvantages, you need to be taught data handling in maths before it can be applied to science. Pupils need to have a basic understanding to be able to use the cross-curricular approach. For example, during my first teaching practice, I took part in assisting the class teacher in a science lesson, where they had to design a bar chart to show which eye colour was the most popular in the class. This was the first time they had ever been set a task like this, so the teacher did not expect a brilliant piece of work to be produced. I have included a few examples demonstrating very different pieces of work. As you can see, I've included a bar chart drawn by a pupil from a higher ability group, and I've compared this to another from a pupil from a lower ability group. The difference is very obvious, with one pupil demonstrating more understanding of the task than the other. At the end of the lesson, the teacher decided that more work needed to be done to ensure that all pupils were making progress. This made me decide to explore the use of data handling from a cross-curricular approach, to see if this would have more of an impact in developing the skills required for pupils. But as you can see, more work needs to be done from this aspect because they did not have full understanding of what they were doing. And this is supported by someone called Piaget, who I'll discuss on the next slide. So according to Piaget in 1958, maths should be taught as a single subject first. He says that to fully appreciate maths, you need to learn all the concepts as one single subject, and there are so many areas which need to be covered, so perhaps this should be done to be able to explore cross-curricular approaches. And Brown in 1998 says that maths is less complicated if taught as a single subject. He believed that more use of assessment could be demonstrated in this way to ensure that pupils remain on target within their learning, and that teachers would have more control over knowing how fast each pupil is progressing. Later arguments show that Barnes in 2012 also supports Piaget's argument by saying subject progression can be difficult to achieve through cross-curricular. So there are a lot of disadvantages in the data handling. However, I think it's fair to say there are more advantages to it, and this will be discussed in the conclusion. So to conclude, it is fair to say the advantages appear to outweigh the disadvantages. To understand and enhance the use of data handling, yes, pupils do need to gain the knowledge of data handling in maths lessons. However, it is unfair to say that pupils should only be taught data handling skills within maths lessons. By using a cross-curricular approach in maths and science, data handling skills can be further enhanced because pupils have the opportunity to use these skills in a practical way. Cross-curricular lessons can be planned to allow pupils to conduct their own scientific experiments and record the findings. These findings can be presented on different graphs, and this will further improve pupils' understanding of data handling skills. It allows teachers to plan more creative lessons through the use of practical assessment and written work, also encouraging team-building skills amongst pupils. Also, another important point that I should mention is that cross-curricular approaches will allow pupils to have more fun and enjoyment within their learning. They're not just at their desks completing written work, but they have the opportunity to try something different. Thank you for listening.